Motivation for using the dy over dx command. So note the information listed here about the dy dx command is for reference only. If you go on to take courses in a calculus sequence, you may want to refer back to this material on how to do this and why. In calculus, we find ourselves interested in the slope of a tangent line. That is, what the rate of change is at a particular point on a function. Now, we're familiar with the concept of slope with linear functions. But with nonlinear functions, we first draw a line that intersects our function at only some point, that is, x, f of x. So what I have drawn here, the image on the right, this illustrates a tangent line to the function y equals x squared plus 2x plus 1. So in blue, I have y equals x squared plus 2x plus 1. And in red, we have a linear function that intersects that function, x squared plus 2x plus 1, at x equals, I believe that intersects at x equals 0. Yeah, that's where it is. So this is the tangent line of that graph at that. So a tangent line intersects at only one point, whereas, and so that tells us kind of what's happening on that graph, the rate of change of that function. There is something called a secant line that you would also see in calculus, which we're not concerned with that right now. Now, a little bit more on that is that if the slope of that tangent line is positive, the function is increasing at that point. If the slope of the tangent line is negative, the function is decreasing at that point. And finally, if the slope of the tangent line is 0, the function is neither increasing nor decreasing. We call this being constant. Thus, at this point, the best use for us in college algebra is determining whether a function is increasing, decreasing, or constant at a particular point. So we can use the function in the next slides to do that.